Okay, let's get started. This is lesson 3 of describing data, part 2. So first we're going to go over a single box plot, and we reviewed before that a 5-number summary is made up of minimum, Q1, median, Q3, and maximum, and these are all used to construct a box plot. And in a box plot, outliers are represented by an asterisk, which is like a little star, and the whiskers on the box plot, which is each end, represent the highest and the lowest values that are not outliers. So outliers are usually outliers that are extremely low or below the lowest whisker, and outliers that are extremely high are above the highest whisker. The box in the box plot represents the middle 50% of your observations. So the lower end of the box will represent the 25th percentile, which is represented by the bottom line. That's Q1. And the upper end of the box represents the 75th percentile, which is the top line that represents Q3. And then the line in the middle of the box represents the median. So in the next slide, I'm going to show you an example of a box plot, and it shows all these, everything that's represented in the box plot. So you have up top the outlier, and on the bottom the outliers are represented by the asterisk. You see the largest value that are not outliers, which are the 2 whiskers in the top that are above and below each of the outliers. Q3, which is the top line of the box. Vice versa, Q1 is the bottom line of the box, and the middle, the median, is the middle line. Together, if you subtract Q1 minus Q3 minus Q1, that's the IQR. So there's a way to identify outliers when you're not given a chart or a graph, which is simply when you're just given the data. So the formula for that is, there's actually 2 formulas, but they're the same idea. So the first one, you find the lower fence, and then you find the upper fence. So it's Q1 minus 1.5 times IQR, and then Q3 plus 1.5 times IQR. So we're going to show an example of this. So any observation below the lower fence or above the upper fence is considered an outlier. So once you find the lower fence and the upper fence, if you have any data that's below the lower fence or above the upper fence, that's considered an outlier. So that's how you know. If there's no data below a lower fence or above the upper fence, then you have no outliers, and that's your conclusion for that. So to show an example of this, we can use test scores. So a teacher wants to examine students' test scores. Their scores are 74, 78, 80, 84, 88, 90, 90, 90, 94, and 98. So I put these all in order. There's 10 of them. So to help you, I put them in their order of in numeric order. So which set correctly represents the 5-number summary from this data? So take a moment, look at the data. First, look at the data to find the 5-number summary. That'll make the options less overwhelming for you. So I'll go over that in a few seconds. All right, so if you didn't get your answer, you can pause it, but I'm going to go over the answer now. So the 5-number summary from this data is 74, 80, 89, 90, and 98, which is B. So if you remember the 5-number summary, if you go back, I'm not going to go back actually, is represented by, first number is the minimum, second number is Q1, third number is the median, fourth number is Q3, and the last number is the maximum. So first of all, I think the easiest are the minimum and the maximum, and once you have the numbers in order, you just find the lowest number and the highest number, and that should be on each end. So first, you can cancel out A, because since 98 is the maximum, 88 cannot be the maximum, so A cannot be possible. And next, the last thing you notice, the most obvious difference next is the difference in median. 89 is the median for our answer, and since we find the median by finding the center of the data, or in this case, there's 2 centers, so we just find the average of 88 and 90, which is 89. So that's how we got B. Okay, so Now that we have the 5-number summary, we can find if there are any outliers present using the formulas with the upper and the lower fences that we just saw a couple slides ago. So here's the 5-number summary again. We can calculate the IQR by 90 minus 80, which is 10. So first, we're going to find the lower fence, Q1 minus 1.5 times IQR, which will give you, if you plug in the numbers, 80 is our Q1, so we subtract 1.5 times 10. We use 10 here because 10 is the IQR. 80 minus 1.5 times 10 equals 65, so 65 is our lower fence. Next, to find our upper fence, we'll do Q3 plus 1.5 times IQR, which when we plug in our numbers will give us 90 plus 1.5 times 10, which comes out to 105. So that's our upper fence. So before we said any scores below the lower fence and above the upper fence are outliers. So in this case, any score below 65 is an outlier, and any score above 105 is considered an outlier. So, are there any outliers present? Take a moment, think about that question, and get back. All right, so the answer here is B, which is no. And the data wasn't given here again. The data was a few slides ago, so you may have had to go back to look at that, but there are no outliers present because any score below 65 and above 105 would be an outlier. And if I go back to the data, oops. There's no score here that is below 65 or above 105, so that's how you get that answer. Just look at the data and compare it with the lower fence and the upper fence. Oh, sure, go ahead. You can ask a question. All right, sure. I'll actually answer your question at the end once the recording is over, if you don't mind. It'll be quick, all right? Thanks. All right, next. So next with, one quantitative and one categorical variable, we can compare these in these variables in in charts, such as a side-by-side box plot, a dots plot with groups, and a dot plot with groups, and a histogram with groups. So here on the right is an example of side-by-side box plots. These are good to compare the median, the IQR, and the range of two groups. So these are easy because you can see them right next to each other. You can compare how many outliers each one has, for example. The size of the median is very easy to tell. You just look at that center line, see which one is higher, which one's lower. You can compare them, and the range is easy to compare as well because you can easily see the minimum and the maximum for each. So next, each of these show a dot plot with groups and histograms with groups. These are good at comparing the shape since they're in a graphical form. They're more of a shape, unlike a box plot. Central tendency and the variability of the two groups, so standard deviation. So distribution for two quantitative variables that we'll go over next are scatter plots, and then we'll be going over correlation within scatter plots, and then simple linear regression. So scatter plots are used to show the relationship between the explanatory and response variables. And so the definition for a scatter plot is a graphical representation of two quantitative variables in which the explanatory variables on the x-axis and the response variables on the y-axis. So these are some things that you can consider when examining a scatter plot. So you can look at the direction of the scatter plot, if it's positive or negative. So the linear relationship between the two variables is positive when both increase together. In other words, as values of x get larger, the values of y get larger as well. So you can also look at the form, if it's linear or non-linear. Sorry. So you can determine if a scatter plot is linear by looking at the line of best fit to describe the relationship between x and y, if it's a straight line that compares the two. This is considered a direct relationship, so as x increases, y will increase as well. The contrary of that is an inverse relationship, so when y decreases, x will decrease, or vice versa. The strength is just how it explains itself as how strong the relationship is. So if it's a weak relationship, it only slightly is related, or one increases slightly, the other increases slightly. But strong on the opposite, they are both strongly related, and as one increases, the other will increase as well. So, and then outliers are just an observation that doesn't fit with the other, the general pattern of the other observations. So that will definitely stand out to you. So here's an example of a scatter plot. So to put all those terms that I just explained, you can see here in the picture. So from the scatter plot of shoe size versus height, we can determine, based on the direction, that there is a positive relationship between height and shoe size. So you can see that as someone's height increases, their shoe size will increase as well. You can tell that it's positive because it goes from the bottom left to the top right. It's going up in an upward direction. If it were negative, it would start at the top left and go down to the bottom right. So it would just be the exact opposite of how it is now. But this is positive relationship. The form, it appears to be a pretty strong relationship. You can tell that there is a definite positive linear relationship there. And there don't appear to be any significant outliers. An outlier to me would look if there was a dot here. I would consider that an outlier because that is the highest height but the smallest shoe size. So that's something I would consider an outlier in this situation. All right, so correlation is next. Correlation is a measure of the direction and strength of the relationship between two variables. So you'll want to know the symbols of correlation. So its sample symbol is just a lowercase r, and the population sample is a row. It kind of looks like a P, but it's actually a row, so you don't want to get those confused with population. So the properties of correlation, since it's a measure of the strength of a relationship between two variables, it can be determined by a number from -1 to +1. So if it is if your correlation is greater than 0, then there is a positive association between the two variables, which means as one increases, the other will increase. If your correlation is less than 0, then as one decreases, the other will decrease as well. So there's a negative association. The closer R is to 0, the weaker the relationship is. So if you see a scatter plot with a correlation of 0, then all the dots will be all over the place and there will be no pattern. So you won't be able to tell any relationship. So the closer it is to -1 or +1, the stronger that relationship will be. It's important to note that correlation doesn't have a unit to it, so there's no unit of measure. I know it's a measurement, but there's no unit associated with it. So it's just talking about strength and direction of the scatter plot. And then the correlation between x and y is equal to the correlation between y and x. So there's no specific order when it comes to talking about correlation here. Okay. So here's just a chart just to give you an idea of the strength, how we define the strength of a relationship. So this is similar in the negative. So if you just add a negative to each of these, except for 0, it'll be the exact same. So the highest, the strongest a relationship can be would be considered at a correlation from 0.8 to 1. And then it just kind of goes down from there from strong to moderate to weak to very weak. It doesn't always necessarily have to be associated with these decimals, but this is just a guideline of how they're determined. So some things to be careful about with correlation. Correlation does not equal causation. So a way that I like to think about this is that some people could consider the amount of ice cream you eat by the number of times it rains per month. So there could be a positive correlation between those two, but it doesn't necessarily mean, but it actually doesn't mean at all that the more ice cream you eat in a month, the more it will rain. There could be a positive correlation between the two, but that does not mean that it happens. And then R should only be used when there's a linear relationship between x and y. So you don't want to make a correlation between data that doesn't have a pattern. And then R is sensitive to outliers. So yes, it is very sensitive to outliers. As you can see here back in the chart, the strength of a relationship can be thrown off by outliers. So if there is an outlier, a relationship could go from strong to moderate very quickly. All right, so next is simple linear regression. So if you remember from algebra, there was an equation called y equals mx plus b, which is very similar to the idea of simple linear regression. So you can use data here to construct a line of best fit. This is typically used to predict a response variable given the explanatory variable. So to predict y given an x. So both x and y variables must be quantitative, and the formula for a sample here is y hat, which is the predicted value for a given value of x, equals a, which is the y-intercept, plus b times x, so plus the slope, which is rise over run, times x, which is your explanatory variable. And then the symbols in the population equation are a little bit different. It's alpha plus beta times x. So it's just a little bit different. So residuals, I think the residual makes it easier to understand the simple linear regression. Residual is the difference between an observed y value and a predicted y value. So it's the actual value of y minus the predicted value of y. So when you're finding the residual, you are typically given you're typically given the observed value of x, and you will plug that into your equation to find the actual value of y. And you can also predict the value of y. So here, I think I have an example. Oh, wait, no, I don't. All right, so you'll be given a value of x to determine y. And that value of y that you'll determine will most likely be the actual value of y. And you'll want to compare that to the predicted value y that they give you to see the residual and how close the observation was to the prediction. So next is relations between multiple variables. So a scatter plot with groups, we just discussed typical scatter plots. They're a little bit different. Scatter plots with groups are used to display relationship between two quantitative variables and then one categorical variable. So if you see in the scatter plot on the right, it shows the scatter plot of weight versus height, and then the categorical variable here is biological sex. So you can tell the difference between the two. The difference between scatter plot with groups and typical scatter plots is that the dots just represent two different categories. So you can tell here that the blue dots represent the females and then the red dots represent the males. So that's just the only difference between other scatter plots. Again, the quantitative variables are on the x and y axis, and then the categorical variables will be represented through the points. These will either have different colors or different shapes, so you can tell the difference. So bubble plots, these are really fun. These can be used to display data concerning up to three quantitative variables at a time, and then a categorical grouping variable. So these, so here in the one on the right, the size of each bubble is determined by the number of days per week that an individual exercises. So here in the graph, it shows height, weight, and days exercising. So height is on the x-axis, and weight is on the y-axis, and then the bubbles represent the number of days exercising. So a larger bubble will signify more days per week per week exercising, and we can see that many of the larger bubbles, which is people who exercise more, tend to fall below the line of best fit, and then more of the smaller bubbles are above the line. Therefore, that basically says that people who spend more time at the gym have larger negative residuals, so they will have less weight. All right, so those are bubble plots, and then next are time series plots. This just is an example of one. They just display time on the x-axis, so time is always on the x-axis in a time series plot, and then a quantitative variable, a quantitative response variable is on the y-axis. So here is just an example. It shows estimated spending, and these are pretty easy to read, so you can tell, like, for example, if you could be asked how much spending was there in 2002, and you just go up to the line that $800. That's how much about $800 is what you spent in 2002. So those are pretty easy to read. Let me see if I can erase these lines. All right. Moving on. All right, so here's a review. So we're going to go back to box plots for this review. So according to the box plot, which of the following is represented by a score of 520? So I'm just asking you this question to find the number on the box plot and say what it's represented by. So take a few seconds, type your answer in the chat box, and we'll go over it. All right, awesome. Yes, C is the answer. So the median is represented by the middle line of the box plot. So right here, this is the median. And then so Q1 here would be represented by this line. And then the minimum would be represented here. All right. Good job. Okay, next question. Which of the following values of R could be used to describe a very strong positive association? So take a few seconds, I'll go over it in a little. All right, yes, A is the right answer for that. So a very strong positive association would be a positive number. That's an easy way to memorize that. So 0.9 is not one of the options as the answer. 0 is not, 0 just shows that there's no association between the two variables, so 0.9 is our answer here. If 1 was the option, that would be the strongest positive association. Oh, those dots. Yeah, I can't erase them. I'm trying very hard. Yeah. Okay, next. Which of the following statements cannot be concluded regarding the scatter plot? So read every option and then type your answer in the chat box once you get it. All right, so I'm going to go over this one. Our answer here is actually B. So the question was asking which one statement cannot be concluded. So we just have to find the one that is false out of all of them. So I'll just start from the top. There's a positive relationship between weight and height. Yes, this is true. If you look, the data is going from the bottom left to the top right. That shows that there's a positive relationship. If there was a negative relationship, the data would start from the top left and go down to the bottom right. So it'd be going in like a downward line. But you see all the data is moving up. Also, you can see the relationship between height and weight. Just you notice that as someone's height gets bigger, their weight gets bigger as well. That's another way you can think about it. So I'm just going to skip C. There's a moderately strong relationship. So yes, there is a moderately strong relationship. there's definitely a relationship present because you can see that all the data is going in a similar pattern with each other. You can see they're not all the same. If that's why it's moderately strong, you can see that there's a pattern though. So that's why it's moderately strong. If it were very strong, the data would be more packed together and more linear. And none of the above, no. A and C are right. But this is not a scatter plot with groups. As I showed you before, a scatter plot with groups has different points on it. So there's 2 categories of points in the chart. So this is only one. Each point represents the same type of category. With the scatter plot with the groups, you would see a different color, 2 or 3 different color categories, or different shapes of the points. So I think that's it. Thank you for watching. If you haven't done so already, please enter your PSU ID in the chat box. If you have any questions, I'll stick around to answer those. My YouTube channel is coming soon. The link will be here, hopefully next week when I finally get my videos up there, but it's coming. I'm working on it, I promise. But thank you.